Yeah, thank you very much for attending. So my name is Georgios Damaskinos. I'm a machine learning engineer at Facebook London. And today I will present to you some of the work we did mainly in the first half of 2020 when I was working at Workplace. Workplace is a product of Facebook that is essentially a communication platform for companies. So let's get started. So I'm sure that many of you have attended multiple conversations or presentations talking about the pandemic era and how important communication is with teleworking tools in this case. And Workplace played a significant role for many companies for ensuring that the employees stay well connected with each other during this period. And there are many ways that Workplace in particular facilitates communication. We talk about a lot of meetings that are going on a daily basis. We have live broadcasts where some leaders can make some announcements. And we also have pre-recorded videos where people can give tutorials or presentations about their work. So we have one-to-one, one-to-many, and many-to-many ways for employees to reach each other and share their work. Now, the really large amount of information that has been flowing into these tools, into these communication tools, creates a wonderful opportunity for machine learning and the AI to provide us with nice features that are quite useful for the employees / users. In this presentation, I will focus on two parts. The first one is focusing on understanding video, and it's about chapters. And the second part is about personalizing video, and it's about contextualization. So let's first start with the chapters. And the motivation here is that we have often very large amount of videos that are also quite lengthy in terms of time. At Facebook in particular, it's almost in a weekly basis or in a bi-weekly basis that we have the leaders sharing some news or having some conversations which last more than an hour. And it's very often the case that a lot of the viewers, in this case employees, are interested to a very small percentage of these videos. And as a more concrete example that you may also be familiar with, you may have observed a similar feature at YouTube. So YouTube also has video chapters enabled. And for me, at least, that's quite useful sometimes instead of skimming through the search bar to go to the corresponding chapter. Now, what we propose here, and to the best of my knowledge, this has been also, by the way, available since the summer from YouTube. So what we worked on the first semester of 2020 is to automatically create these video chapters by using machine learning. And this is a good solution because we have a large amount of videos and we cannot have an equally large amount of annotators, of human annotators that can go and create the right chapters. So why is this challenging? As you can imagine, as I said, you have a lot of videos and not a lot of people who can go and manually annotate them. So we don't have a lot of ground truth to train our models. So we are following an unsupervised approach that we use pre-trained embeddings trained on different contexts. And we do that to create the chapters. Now I have put a pointer here, reference to a work we published along with my colleagues at Workplace. And I encourage you to look further in this paper for details and to reach out if you have questions, of course. We also have the code open source, so feel free to play around in GitHub. Now, to describe this, the procedure that we do for segmentation in a nutshell, so that it's understandable by everyone. So we have the sentences that the speaker of the video is creating. And what we want to do is create a representation of these sentences, often called in the natural language processing literature as embeddings. So this is pretty standard, and there are well-established tools, models for doing that. And what we essentially want is given two sentences that are similar in terms of context. So here, for example, the red part, we talk about the jungle, and on the blue part, we talk about the forest. So we want these two representations, these two vectors, to be close distance-wise to each other, or at least closer than a third sentence, which is talking about New York. So we focus on well-established architectures, namely BERT, for doing that. And we use basically BERT and sentence BERT, which is a follow-up, a more recent follow-up. And this is the high-level description of our chapter generation procedure. So this is how we, what are the steps that we take? So first, as I mentioned before, we compute some sentence embeddings. And then we go, we parse these embeddings in a chronological ordering, and we compute how similar adjacent embeddings are. And by computing these similarities, we essentially create a curve that shows the probability, the topic change probability. And so on the y-axis, we have the topic change probability. On the x-axis, we have the time. And then we have a heuristic-based approach to create the segment. So we set some parameters based on what is the maximum number of the duration that each segment can have, or how many segments we can have in total. And after setting some parameters, we can create a segmentation for this video. So essentially, we put some lines in our curve, and we say this is where most likely there is a topic change. So people in the meeting, for example, start from talking about I know some social activity to going into something more related to work. And then for the final part, we take these segments that we created and we extract headlines. So based on the context of each segment in separate, we create a title that we then use as the chapter title. And here on the right, I have provided some of our results, and these results are available in the study that I have mentioned before. So to go through this, these results are with respect to meeting datasets, namely AMI and ICSI. And we have the following methods that we evaluate. First, we have a random method, which randomly assigns these topic chains, like these segments, it randomly creates those. We have the even, which assigns a segment every second sentence that is being pronounced. And we have the text styling, which is the main unsupervised alternative. Although text styling is a pretty, let's say, old approach, it constitutes the only unsupervised method so far. And we compare against a BiLSTM network that is trained in a supervised way based on Wikipedia data. And finally, we have our two methods. So our segmentation based on BERT and our segmentation based on sentence BERT embeddings. And as you can see, we outperform the alternatives. So we measure performance based on PK and WinDiff. which are essentially capturing how close our segmentation is to the hypothesis, to the ground truth. And the lower, the better. So as you can see, even for the supervised approach, we are able to get better performance since we have a different context. So the context of the meetings is most of the times not very related to the Wikipedia data that the supervised approach is trained on, thus highlighting the need for a unsupervised method. Now, with a substantial amount of effort from UI engineers and designers and user researchers, we have created an experience, a UI for this tool, for this chapter generation tool. So the end experience at workplace looks like this. So we have a user that can go, basically first we have a video that is generated, and this video has the option to have automatically generated video chapters by using our methodology we just described. And the user has the option to edit those chapters or manually create new ones. And at this point, I will move on to the second part of the presentation, which will focus on contextualization. So it's another very common feature, quite important one for accessibility and audience reach, is that of video transcription. So we want what's being said to be transcribed into the same or a different language. And we want that to be happening both for live presentations and offline presentations. The live ones are much more challenging because you have significant latency constraints there. But this is not the main topic of this presentation. So what the problem that arises from this procedure, which we call automatic speech recognition or ASR, is that in work environments, we have a lot of context. So we have a lot of names, a lot of acronyms, and a lot of domain-specific terms. And especially at Facebook, there is a lot of jargon, and the jargon is very team-specific, not just within the company specific, but each team has its own way of communicating, its own words that are accelerating communication. And standard automatic speech recognition tools are, of course, not able to capture these terms and end up in mistranscriptions that prohibit understanding or the general procedure of following what's being said via the transcription. So what we propose is to bias this procedure by out of vocabulary words. And so this procedure is more involved, and I encourage you to look into this paper published by our colleagues from the ASR team to get more context about what's the procedure, what the details of this procedure. In a high level, what we have is a set of context or out of vocabulary words, which can be, for example, Android, Anna, and PyTorch. If you put PyTorch, if you pronounce PyTorch to a standard ASR tool, it will transcribe the words pie like apple pie and torch separately. So we want to inject those. We want to bias our prediction based on those. So we organize these words in a trie. Trie is a data structure, which is basically a prefix tree. So in our case, this looks like the image I have on the left. And while the speaker is speaking and saying movies with an, this trie is being traversed. And at this point, we know that on top of candidates, of classical candidates like another or and, we also have this out of vocabulary words named Android and Anna. So there is a bias term that can have these, can make the prediction for the next word to be one of the out of vocabulary words. And this was the biasing module. And then as typical in natural language processing, attention is helping these predictions to be more accurate by helping to capture the relative connections between these out of vocabulary words given the context. So what is the position, what is the relation of this word in the given sentence that is being pronounced? So we want to have a feedback loop, and we want to create embeddings of these words. So W1, W2 is Android, and so on. We create embeddings, and then we use an attention module to better capture this relative relation, this relation in a given context. So with that, I would like to conclude my talk and mention that we talk about two things: video chapters and video contextualization. The goal of these topics and these tools that we introduced is to maximize the throughput of information received by each user. So we want to minimize the time that it takes for a user to take a given amount of information. We don't want the users to skim through all the video to get the right the content that they want, and we want users to be able to quickly comprehend what's being said, even if it's on a different language, or even if they cannot hear the video because they could be impaired, or they cannot listen to the video at that point, and they can only read the transcript. So I would like to thank you for attending this presentation. And this is the main contact, so you can find pointers about the work I mentioned earlier, and pointers to the code. And you can also find contact information for myself. So feel free to reach out in case you have any questions. So I'm happy to take questions at this point as well. Thank you.